Hello everyone, my name is Hoyamut Mujumdar. I am a graduate student in the Department of Chemistry, UTRGV. Today my topic is Sustainable Three-Dimensional Fiber-Shaped Dye-Sensitized Solar Cell using Carbon Nanotube Yarn with Photocatalytic Activity of Bismuth Oxide Iodide Titanium Dioxide Heterostructure. The purpose of this research is making a sustainable solar cell which will be more feasible environmentally, economically, and socially than the conventional solar cell. Let's talk about the introduction to dye-sensitized solar cell. Dye-sensitized solar cell is based on a semiconductor, including a photosensitized anode, an electrode, and a photoelectrical system. The mechanism of DSSC is very simple. It consists of two electrodes. When the photon hits the semiconductor and is sensitized, the sensitizer gets excited from ground state to excited state. The electron moves around with the help of platinum dioxide nanoporous layer. It moves from one area to another electrode, which will eventually create electricity. Now we will talk about the materials and method of this research. The preparation of my research work is divided into 5 steps. First, preparing the working electrode, preparing the photocatalyst, preparing iodide-based electrolyte, preparing the dye, and cell fabrication. Preparing the working electrode. I prepared the working electrode with different kind of solvent washing and then put nanosol titanium dioxide layer onto it. The biocompatible photocatalyst making procedure was very easy and less costly. It was done within very low temperature, like 80 degrees Celsius. The chemicals used in this research was bismuth nitrate 5H2O, potassium iodide, and titanium tetraisopropoxide. The electrolyte preparation was simple, and the cell fabrication was done with the working electrode, which will be immersed in dye 9N719 for 24 hours. Then the platinum wire with 0.05 millimeter diameter was used as a counter electrode. Iodine-based electrolyte was applied between two electrodes. You can see here I have put a picture of the fabricated cell, which looks like a small hair, but is capable of producing electricity. Here is the XRD of the photocatalyst, which shows sharp peaks. That means it is capable of working as a photocatalyst. The right side graph is a curve, which is current versus potential, which shows us that it has created current and potential, which can be applied for making a solar cell. Now it times to talk about the result and discussion. Here, the result I have divided into 3 portions, which is economical sustainability, environmental sustainability, and social sustainability. While discussing the economical sustainability, we can see in the chart that the solar PV cost $0.038 per kilowatt hour, but the cost per watt for DSSC is still less than $0.010 per kilowatt hour. In 2019, the average price for electricity in Texas was 11.67 cents. For Rio Grande Valley, it was like $0.06. If the system is 11 to 17 kilowatt, the average cost will be $0.03 per kilowatt hour. For 18 plus kilowatt, then the cost will be more or less same. The main concept of this project dye-sensitized solar cell is to reduce the average cost more and more. If we talk about environmental sustainability, we can see from this chart I have given above, the gas power plant results in about 450 gram carbon dioxide in per kilowatt hour electricity, but DSSC system with 20 hours lifetime would result in between 19 to 47 gram carbon dioxide per kilowatt hour. In Texas, the emission of carbon dioxide is 653 million metric ton in 2016, and the only emission for electricity is about 124 MMT. Emission for solar PV is 3348 MMT. After using DSSC, this amount can be reduced to 50%, which will be like 16.74 MMT, which is very less compared to the other amount of carbon dioxide emission. If we talk about social sustainability, it says it will create a job market, no health hazard, and no air pollution. So to conclude the whole project, we can say it's a new source which can be implemented way cheaper cost than the conventional solar cell, more mobile and more recyclable, flexible, and the noble photocatalyst was used, which is environmental friendly. So we can say this project is sustainable for the society and environment.